Hello, everyone, and welcome to this Elektor webinar. I'm Brian Tristam Williams, and today we're talking about something that's on a lot of minds, solar energy storage, what it takes to set up a system, the components involved, how much it costs, and the trade-offs between DIY and ready-made solutions. So if you're thinking about energy independence and reducing your reliance on the grid, or you're just curious about battery storage, you're in the right place with us and our expert guest. Before we jump in, though, I'd like to welcome Elektor's editor-in-chief, Jens Nickel.
Hello, Brian.
Jens, great to have you here. I'm great, thanks. How are things in Aachen?
Very good, yeah.
Awesome. Well, Jens, we've been through an editing process with the power and energy-focused edition, which I was lucky to get in time given our post office. And the whole issue is about that. But our first article is a 7-page article by Dr. Thomas Scherer. And it's very in-depth and very interesting. I've been told by other people that they found it very interesting as well. So we thought, since our topic for January-February edition is power and energy, there is Dr. Scherer there. And we thought, why not have him on the show, if you can see that, for our webinar. So let's introduce our special guest, Dr. Scherer. Thomas is an expert in power electronics and energy storage, and he has a deep understanding of battery technologies and how they fit into real-world energy systems. So whether you're considering a small backup system or a full solar setup, he has the insights to help you keep informed. So Thomas, welcome, willkommen.
Hello, welcome to all over the world, to our viewers.
Yeah, the chat room is full. We had over 600 registrants for this, so that's quite a big deal.
Yeah,
but before
it's a very popular topic.
In
fact, it's not the first time we have Thomas in the show. We have last year we had a webinar about balcony power plants.
Yeah.
And Thomas wrote more articles about balcony power plants and now do-it-yourself battery storage.
I know Thomas is now our resident go-to expert.
Yeah.
Before we move on, though, I'd just like to talk about our sponsor, EENewsEurope.com. If you're looking for the latest electronics and engineering, there you have it, EENewsEurope.com. You're looking for the latest in engineering and so on, go there. They even have a power section, which ties into our topic today. It's a fully digital publication covering the global electronics market with special focus areas including analog, automotive, embedded, power, smart 2.0, and wireless technologies. So stay informed about essential industry news, key events, and technological innovations. Visit EENewsEurope.com as you see it there on your screen, and subscribe to their newsletters today. And of course, for our audience joining us from around the world, welcome to you. Just taking a look from France, Berlin, Belgium, Denmark, Northern Germany. And if you're a regular viewer, you will know we have giveaways on these shows.
Brian, there's a little bit feedback about some technical problems. Some people didn't have audio, but there's a suggestion by another viewer. You have to reload the StreamYard page.
Okay, well, hopefully that works because I can hear you. Yeah, I'm monitoring on YouTube now and we're doing fine. The audio is coming through. So this is the book we're giving away. It's a giveaway for today. It's Renewable Energy at Home. And 3 lucky viewers today will receive a copy of it. A no-nonsense book that walks you through building your own renewable energy system at home, whether you're interested in solar, wind, or even unconventional manure-based power sources. This guide is all about real-world application with minimal theory. So if you're the kind of person who loves getting hands-on with DIY energy products, this book is for you. How to enter? Well, it's this tab here. We'll give you the URL. Just visit our page, and you'll have to fill in a code word. And I'll give you the code word later, as always, after the presentation, and then we'll take questions from people around the world. It's a very busy chat room today, so I won't waste any more time. I'll move on to Dr. Scherer, Thomas, as you allow me to call you.
Yeah. Okay. So solar systems or photovoltaic systems are I think the most hot topic in today in 2025, especially because the prices dropped last year so heavily, that you pay in 1 year only 40% of what you have to pay last year. And when I bought some solar panels last year, I had to pay about 125 euros per panel for 425 watt panel. And today you can buy that between 40 and 50 euros, depending on the amount of panels you buy. Even the inverters had come down to half the price. The batteries have come down to less than half the price. So if you buy now, you have it really cheap, especially if you build it yourself, because the solar companies, they have a high amount of work to do. They can keep the prices high and don't give the low prices to their customers. So the difference between doing yourself and buy it from a solar company is very high in the moment. So you can, you can earn a lot of money if you do it yourself. At least an example, if you build a normal, for a normal house like mine, 10 kilowatt system, then you have to pay about 6,000 bucks for materials, 6.5 with battery. And if you let do this a company, you pay between 15 and 25,000 euros for the same system.
Thomas, this brings me to my first question. What can you do yourself? What are you allowed to do yourself?
Everything, but not in the meter box. Yes, especially in Germany. Every country has different rules. So maybe in America, it's a little bit different. You can do a little bit more yourself, but not in Germany. It's absolutely not allowed to do anything in the meter box.
But you can go to the roof yourself and do all the cabling.
Put the solar cables to the inverter, connect the inverter.
There is no one checking. There's no one checking that it doesn't come down the roof or something like that.
Nobody is checking. It's your responsibility. Okay. But the end is that if you want to have connected the whole systems, you need a certified electrician, which makes the last work. Setting the meters in the meter box and so on.
But that goes only for grid connected.
For the grid connection, and he has to certify that it's okay, to approve that. And it's his duty that everything is okay. He can say no.
What are the costs roughly for such an approval?
Typically, I know it from my one friend from a week ago when we finished his solar system. He says he has to pay a good friend, certified electrician, between 500 and 1,000 bucks for work and approval and filling out the papers to register the system at the grid providers.
I see.
So, and most certified electricians don't do that because if they are working for a company, they make a concurrence to their own company, or
I see.
or the company says, I don't do that because I can get 10,000 bucks of difference if I do the whole work.
I see.
So why should
you must find someone.
You must find someone. And there are, even in the internet, there are some websites like My Hammer, you can ask.
Okay.
But you have to calculate 500 to 2,000 bucks just for the stamp on the complete thing.
And the solar system yourself, you can do if you want. If it's your own house, you are free to do.
It's your thing.
You don't have to ask anyone.
You don't have to ask anyone, even not in static experiences. It's your thing. Okay. If you make errors, if your roof is not solid enough to wear that, or if you don't fix the panels tight enough, then you have a storm, they go up. So it's your responsibility. You pay for that. But if you're a good worker and have some experience in electricity, it should not be a problem.
And you can, on your property, you can put solar panels everywhere on the outside. And
normally yes, but the distance to neighbors in Germany, German rules are distance to neighbors has to be 3 meters. And they can, if you make them much shadow, no? If you make a big roof just for solar systems, they can say, hey, this is not okay or so, no?
I see.
And the neighbors have maybe sometimes to speak about, and even in some regions there are protected areas where you have to ask, or if you have a historic house, no? Another friend, they have a photo from, he's, the city guys say that he has to use red-colored solar panels, which are very expensive and less effective, no? And so, but in 90% of the cases, it's no problem.
And is there a size limit?
Yes, there's one, but not a lawful one, but there are two limits. First limit is 10 kilowatt peak of installed solar panels. After that, you get a little bit less money from the grid if you feed it in the energy.
But
so
they have
can
to allow to connect it to the grid, even if you have 30 kilowatts and 50 kilowatts.
It's allowed. Okay. Then you for sure need more than a certificated. Then it's not so easy. Then you have to make taxes. You have to build a little company, you know, for all that. It's
what is the limit to have an own company and to
30 kilowatt peak.
30 kilowatt.
And then the rules are completely different, though even nowadays they can shut off your inverters, no, from remotely if you are over 30 kilowatt, no? But in the moment it's not allowed, or there's no law for shutting down your inverters in the moment. This will happen maybe until the new political rules will come, because this year, in the last year, we got about 25% more installed solar energy in Germany. And then in spring, the energy provided will be so high, even the French people can't even use all that energy is coming from Germany. They have to cut all their power plants down, and this is not enough. Germany has to pay billions for the waste energy. No? They can't do so. And not only that, the energy could be so high that they have to switch the grids down. Then they have the first power out since World War II, I think. And this will make very fast changes in the rules we have. So if you plan to install solar, do it now.
Okay.
And don't wait 2 years.
You have a luxury problem.
Yeah, it is.
Here in South Africa, they battle to keep the grid up, and you are contemplating them possibly shutting it down because of too much power.
Yeah, exactly. Should give it to South Africa. But even South Africa, so good weather, no? They have even space for that, no? You can do that, and it's so cheap, no? Though I think the politics should push these solutions a little bit more in other countries.
Yeah. And you say now is the time to get in.
Yeah, in Germany it's now the time to get in. I think in France too, because they have the same problem as we have, but they don't pay so much money for installing. Even you can get a little bit help from some communities, get a little bit money for that if you install still in the moment. And it will stop, I'm pretty sure. And even we have reduced sales tax on everything what has to do with solar systems. Well, so you don't pay sales tax, 90%. It's a good part of the deal. Maybe it's over at the end of the year when we get new government. And time of registration counts.
Coming back to the sizes of solar systems, what is the size of a solar system we are talking about today?
If you have a one-family house, standard house, about 120 to 170 square meters, rooms and so on, you can have on a typical normal roof maybe between 8 and 10 kilowatt watt peak,
Okay.
not more.
So
There's
we
not
are
much
not
space.
talking about balcony power plants today, because that is, I think, important for the audience.
Battery power plants, it's the same. It's easy. 2 panels, or you can use 4. It's allowed until 2000 watt peak in panels, but the inverter has to be restricted to 800 watt output. And you can buy them everywhere. They are cheap.
And is an energy storage with batteries also an option for balcony power?
Yeah, they're coming this year. They're coming good ones, but then you have to install a smart meter in the meter box, no? Because the battery has to know if the energy is going out, no? Then reduce or take the energy which they have to put it into the battery and outside. Don't put so much energy into the grid that the grid is fed from your battery, because their batteries are small. They have about between 1 and 2 kilowatt hours.
Okay, and the smartphone, a smart meter, you have to buy yourself. You are not getting it from the...
and you need again a certified electrician who installs the smart meter in the meter box, and then you have connected through Wi-Fi or cable, better Wi-Fi, to your. And the first ones between 1,000 euros up, you will get this year, which are good ready-made solutions. But until now,
it's a ready-made solution, battery, inverter,
exactly.
and so on.
And until last year, so more solutions, or nearly all, don't have the opportunity to measure the current risk going into the grid, out or in. So you can only adjust the power you get at night between 100 watt, 200 watt, 300 watt, and the battery is really relatively fast empty, and you have many cycles on your battery feeding the grid, which you get no money for. That's not a good idea, or not efficient to do that, and at least not economic.
Okay. Then coming back to the 10 kilowatts solar system, there are different calculations. Is it worth it? Because the first calculation is the solar system as is worth the money? And I think you have a clear answer on that.
Yeah. I've made some slides, and on the last one there are some calculations, and I can say now that every kind of a solar panel you mount on your roof is worth to do that. Every kind. If you have a battery or not, both is worth to do that. You earn money with that. No? The return of investment is high, even if you buy this extremely high prices from solar companies. You have a return on investment between 5 and 10%. And if you make it yourself, you have a return of investment between 20 to 25%. See, so after 4.5 years, you just get money. And not speaking about the feeling that you have green energy. And since I have that, I start my washing machine only when the sun is shining and so on.
Okay, Thomas, you have a presentation for us.
Yeah.
Before we move on to that, I just want to welcome our guests. I won't have time to get to all of them, but just show you a sample of the world: Peru, New Mexico, the Netherlands, Scotland. Hallo aus Aachen, that's down the road from you, Jens, and I've got someone down the road from me. Charles Petersen says, Goedemiddag from Pretoria, South Africa. Romania, we've got all around the world. So Thomas has a presentation for us, and promise we'll have fewer interruptions based on that comment. We'll let Thomas continue with fewer interruptions during the presentation.
No problem.
Drop your questions in the chat. There are going to be a lot of questions, Thomas, so hopefully we'll be able to get through before the hour is done, but I wish you luck.
Yeah, and I like to be interrupted. So, because questions help. So, this is a slide which shows what parts are required for building a solar system on your roof. You see, what you need are solar modules or solar panels. Typical size is between 400 and 500 watt peak. So 500 watt peak panels are in the moment not allowed in Germany, but in most parts of the world they are, because they are bigger than 2 square meters. It will be changed soon, I think. Then you can mount bigger ones. But for doing yourself, the smaller ones are easier to handle because they are very heavy and big. No? So if you have a panel which is 2 meters long and 1 meter 30 wide, how to handle with 2 guys on the roof is makes no fun.
You
So
must have a van to transport them.
You must have a van. I have a little trailer even for them. For this one, it is too big, the 500 watt panels. I can only put 425, 440 watt panels on it. Yeah, most important thing is they got extremely cheap. A friend of mine bought in January a whole pile of 40 panels, and he got a price for 42 euros for 435 watt panels, first grade. Best thing covered on my side with glass, so light can come from both sides. For a normal house like that, if you stay just under the limit of 10 kilowatt peak, you need 20 to 24 modules. It's not so much. So one is about 1.8 between 1.8 and 1.9 square meters. So calculate that what you need on space. Then inverters or 2 have come down very, very heavy. Today I saw a small inverter for 4 kilowatt inverter for $200, which is ridiculous. Last year you have to pay more than 200 euros for an inverter for a balcony power plant with 800 watts. And this is too, you can't connect so many. You can't connect 24 modules in series because the voltage then you would have is about 1200 volts, which is on the limit of the cables, of the insulation of the cables. And even it feels a little bit dangerous for me to get that high voltages. And even most inverters have a limit. You should below 1000 volts. And in an optimal range would be between 400 and 800 volt. So you need 2 strings, which means you have 2 CAS connected parts. You have maybe if you have 24 modules, two strings which 12 modules each.
Okay.
And I will show you the solar system of this friend, which made it last week. Doesn't work. No, now it does not work. Now I see. Yeah, it does work. This was it. You see on the left side, he has 3 strings on different side. On a little house on the side, on a pile of wood, and on a little path where he put it as a fence. So 12, 13, and 15 panels he had. So together 50 kilowatt. So
is it another question? Is it good if you have the option that you, for example, change the angles of the solar modules, so you have some to the west and some more to the east and something like that?
If your house like this one is more north-south orientated, mean this side looks to west, and here you see the roof here on this side. See my hand? Yeah, here the roof.
Yeah.
Then here is south, and the other one is north. Then it makes no sense to put some panels on the north side.
Yeah.
Everything on the south. But if you change this at 90 degrees, it's a good idea to put east and west, because then you have solar power the whole day, from early morning to very evening. In summer, when you have an AC machine here, make it cool, no? You need energy even in the evening, especially in the evening. So it's a good idea to do that, and the reduction in efficiency is not so high. So one neighbor which has a house here on the other side had done it both sides with equal amount of panels. 14 panels on both sides, 28. So it's way over 10 kilowatt peak. And has 4 strings, then a big inverter.
Okay, as the modules are so cheap, you say the more the better.
The more the better, because
okay.
If you buy that and you have space, put it on top.
Okay.
And if you lose this 1 cent on the limit between 10 to 30, lower than 10 kilowatt and up over 10 kilowatt, so if you get 20% more energy,
each of the module is counting with its peak power.
Yeah, with the peak power. The inverter is not important. The limit is only depending on the installed modules.
Even if they are oriented to north, they would
installed power
as full. Okay.
Yeah, even if you cover half of them, it's the installed power. Okay. And someday makes sense if you plan later to add another string on another roof or so. No, you can think about buying an inverter which has a string more.
So you have the option.
Exactly. And even if you have different light on your panels on the east or west side, maybe then you need at least 2 strings.
Okay.
Because then you can't count it in series, because then one side is blocked and from the other, and the energy is not high enough. So the lower light side will be just ignored, which would be a pity, no? And with different strings, you can prevent that. And even if you have trees in that, there are little electronic circuits which even you can put on it, which make the efficiency better. But I won't do that, because the anti-parallel diodes will do the job normally. Because one of these little things costs about 25 euros, no? Half the price of a panel. No? Therefore, I would prefer to buy more panels.
Yeah, I understand.
Instead of tricking. Battery. Next time. In the moment, only lithium iron phosphate batteries are the battery type of choice, because
no lead acid anymore.
No lead acid. Never has been. I think because they are not. The efficiency of lead acid batteries is very low with high currents. So you waste energy about 20 to 30%, and the efficiency of a lithium iron phosphate battery is way over 90% between loading and taking out the energy. The most important thing is that even the prices have come down extremely. I know 6 years ago, if you could buy a battery system with 6 kilowatt peak for about 8,000 euros. And meanwhile, you can buy a complete battery with 10 kilowatt for 2,500 euros, a ready-made one. And if you build it yourself, you pay half the price. But building yourself you should do it only in 84 volt technology, because the high voltage and high currents is a very risky thing. I never would work on several hundred volts, which so high currents which can occur there. And the higher
the smallest module you will buy is already a 48 volt module.
No, it's a technology, because there are inverters which are low volt, which you can connect. You call it hybrid inverters, which has the opportunity to connect a battery. And one type is that you can connect low voltage batteries, which are all 48 volt. Or 51 in reality.
But you get it as 48 volt battery. So no one is buying the cells in China and building it himself.
Yeah, some people do. I can show you even there. This guy did it. It's Martin, a friend of mine, which made it himself. You see here the cells he bought, no? And here's an actual combined package. You can buy everything in one package for 1,314 euros from China. No? And you have 10 kilowatts then.
And what are the specs of these prismatic cells? Because
200 amps.
Usually you have the small round ones.
Yeah, this is a 200 amp cell.
Yeah, okay.
So multiply with 50, you get about 10 kilowatt. And in the picture, you see the battery built in this wooden box. No? You see all the cells. They are not small, they are this big. No? And they weigh several kilograms each.
And the voltage is 48 volts.
Yeah, and there's battery. There are as many connected that it for 16 cells give 50 volts or 48. And he has a battery management system which with a data line, and the inverter has to be connected to the battery management systems, because he has to see if the battery is full or not, no? And if the cells are all okay.
So the voltage of one of these prismatic cells is 3.7.
Please, I did not understand.
What is the voltage of one of these prismatic cells?
Typically 3.2.
3.2.
Typical voltage of a lithium iron phosphate. The ordinary lithium CMP batteries have 3.6, but you can't use it there. The Panasonic sold several of them battery systems, and even in the neighbor community last year, one got in flames, burned down.
I see.
This is why the idea from Tesla or Elon Musk selling the old car batteries to houses, which would be a really good idea if you get a 50 kilowatt battery, kilowatt hours battery in your home for not much money, would be really good. Even they would last for long, but if you get fire on the thing, your house is away. And they have, I think, you have been sure that the insurance price is going up then, if you even try that. So the only way to store energy in the moment is, for practical purposes, this kind of cells.
Okay.
So, okay. And even, see, half the price you can, I'm not sure if I would do that in the moment myself. If you have fun in doing it yourself, okay. Even Martin will do the next big battery for his boat to be independent when he has a big iron boat in the Netherlands. He's shipping around that as a hobby, and then he want to be 1 week with energy and can cook with. He want to have a 15 kilowatt battery in a boat.
I see.
Then what you need is a smart meter, which is a meter which has to be installed in the meter box and connected to the inverter, so the inverter knows if the energy is going outside or inside and how much. It's very cheap, they get it, but you have to look for the suitable type for the inverter, because there are different ones. All cost about around $100, not very expensive. They are really simple. This is a iron core around the wires, and the little microcontroller who measures the current and gives it serially with errors 4 to 2 to the inverter. So you can even read that out.
And why does the inverter have to know that the energy is going out or in?
Please?
Why does the inverter have to have this information?
So if a normal inverter does not need that, if you don't have a battery, but if you use a battery, then he has to know if it's time to load the battery, and he does it first before he gives energy to the grid first.
So the inverter is controlling the battery charging.
Exactly. First charge the battery, second the rest of the energy, sell it.
I see. And
even if in night, when there's no more solar energy, if you use the energy from the storage from the battery, he has to control that there's not only such an amount of energy put into the grid that it's not going outside. Just use the energy you use in your house, so the battery lasts long. So you can calculate, if you buy a battery, a ready-made battery, then you can calculate, you have to pay for the battery. The cost is, for the lifetime of the battery, about 3 to 5 cents per kilowatt hour. for using stored energy. Makes sense, nevertheless, but you have to look to that.
Will the situation change when we have these time-dependent fees for currents? So the price is changing at the days?
This is no, I don't know an inverter which will take this in account. Maybe in the future it will come, because companies.
When do you think that will come? When do you think that will?
2 years.
Okay.
Not in the moment, because it's really complicated.
But then everyone needs another inverter.
Inverters, even a typical inverter will cost about 500 to 1,000 bucks. And if you need a bigger one, even Radi has did buy an inverter with 3 strings with 25 kilowatt, and it costed about 1,500. It was a cheap one. There are more expensive ones than he bought, but it's not so. If you really think you get more money if you use this time dependent thing, then you have to. You have to calculate that it makes sense. In the moment, it makes no sense. Or you have to do everything your own and make it really control. But for most people, even for me, it's a little bit too complicated to do that, because you have hundreds or thousands of hours to plan and calculate and test and so on. And if you do that, everything, there's a limit. Everything you would connect to a grid has to be approved by the manufacturers. You have to be a serial number and an ordinary stamp. And if you register this, it has to be approved material. Otherwise, you get no allowance to connect it to the grid. If you do it yourself, you don't have that.
So you cannot buy, you cannot build your own inverter, for example.
You can build, but then you have to get the stamps on it. No? You get them, let them check, and then it's so expensive. No? Then
I see.
Forget it. Don't
so
build your own
inverter. Inverter yourself, it's only applicable for a solar island system.
For islands, exactly. For your garden house, or if you have fun and with low power, I would prefer not to test this on a battery. Because think about such a battery, a 48-volt battery, can give about 1,000 amps.
I see.
Multiplied with 50 volts, you have 50 kilowatts. If you make an error, and everything is destroyed, material is going in every side. It's really dangerous.
Okay.
So next is miscellaneous mounting materials. Is clear. This is all this aluminium parts you need to count it, and screws and all the things, and cables and plugs and so on. Should calculate, see, between 400 and 1,000 euros, depending on your roof type and what you are planning. And then the installation. This is a big thing. See, a calculator is just a rough calculation or rough estimation that typical cost for a solar system, if you buy it from a solar company, will cost about 1,000 euros per kilowatt hour or more, or double. So between that, and so this is, if you have a 10 kilowatt solar system, you can get this 10 kilo euros by your own. In doing this is even a good, a good price for your work. You can work, at least if you work 1 month on it, which you don't do. It's a really simple solution. Connect the panels on the roof, or the lines, connect it to the inverter, connect the battery. You should use maybe a week, alone or with a friend. And this for 10,000 bucks. It's a good job. Okay, from that to the next. It's simple to say this is a basic circuit of a hybrid inverter. Hybrid means you can connect a battery to it. This is a hybrid thing, like in a car. with the combustion engine and battery. You have solar panels, you have the inverter, and inside there's a controller, charge controller and a boost converter, and it gives the energy controlled by the controller to the grid or in your house. On the right side, you see the basic circuit of solar battery. It's only with 4 cells. No? So you get only a 12-volt battery with that. You need 4 of that for 48 volts or 16 connected in series. And you have a battery management system which even checks the voltage of every cell every time and gives an alarm if something is wrong, if the voltage is too low or so. Stops charging then. The hybrid inverter will stop charging if something is going wrong. And you can even read the information out, usually with software, and see how good is a battery working, if every cell has the same amount of voltage and so on. Yeah, this is connection to controller of the inverter on the right side. So it's very simple, nothing complicated. And this is shown the prismatic cells and the price and the system which my friend built at this home. And he has here very expensive inverters. This is a charge controller, what you see. And inverters this is an inverter in the background. You see 2 charge controllers from 2 strings. It's a simple system built on its own. There's only charging and the inverter, and the inverter controls all that, but different devices. Normally you have charge controller and inverter in one case.
The inverter just says to the BMS, charge it now or not.
Exactly. Okay. Yeah. And yeah, okay, it's a very old house. So this is a guy who is only allowed to get red panels on his house.
I see.
Because and the whole street has red roofs.
I see.
So, then this is on the right side. You see typical ready-made battery. The cheaper ones cost about $2,500 per 10 kilowatt hours. You see the single modules. What you can see in this photo is on the top. There's electronics inside the battery management system.
Thomas, this price of 2,500 euros, if you buy it yourself in China, or it's
no, if you buy it in Germany.
Buy it in Germany.
Just order it in the internet, online. And this is what you see here is at 25 kilowatt. 5 moment. 5? Yes? No, a 20 kilowatt solution. Every module, which is put on top of each other, has 5 kilowatt. So you can, if you think afterwards, after half a year, oh, maybe my battery has not enough capacity, you can buy a separate module of 5 kilowatt hours and put it on top. Sorry.
Now you're muted, Thomas.
You are mute.
Exactly. And I would say if you have a single family home, then you should start with at least 5 kilowatt hours. 10 is really good, and then you have maybe for 2 days, if it's full, energy for 2 days. If you calculate it, typically.
And more?
More, yeah, will cost more money.
Okay.
But the efficiency over time, I calculated that is not really good. You will see in the last slide where some calculations where there you can see if it makes sense or not. So most people think more is better, but not in battery, I think.
I see.
Even you don't use the battery so much in a typical home, so it will last more than 10 years without problems, even 20, I think.
I see. So
in 10 years, you will get about 1,000 to 2,000 cycles normally, full cycles. And such a battery can last between 6,000 and 8,000 cycles. So it will die from rust or so, maybe, not from usage.
I see.
So next, yeah, this is this is a solar system of Radi from last week. He has 3 things. You see that, and in the middle you see the smart meter, such a little thing, device where the three phases going through from the grid. After the meter from the grid, then the smart meter comes, and this smart meter is connected with RS422 to the inverter, and on the blue one you see the first earnings. Here in the moment had 1.53 kilowatt. It was completely clouded then and a little bit rainy, which is good for 15 kilowatt peak system. And I think he will add some panels more, because he can add 15 panels per string without problem. And here it's on the lower house he has 12, and on the left side on the wood pile he has 13 or so. And he will dismount that and will make more here, 15 too. On the right side you see the inverter on top, and in the back you see the meter box, which is really big. And below is the battery. You see, on top is the 1/3 of that is the battery management system on top with a black dot on it, and then 2 5 kilowatt modules. And he has even space enough that he can add one more. He will think about adding one more, because it makes it big, likes make it big. But the calculations speak another word. Here are the calculations. This is a typical one-family house with 2 parents and 2 children. Uses normally in a modern house 3,500 kilowatt hours per year, which results in cost of about $1,000 at 30 cents per kilowatt hours, which is a cheap calculation. So maybe this year prices will go a little bit up between 32 35 cents per kilowatt hours, if not other rules come. Even in France, the prices, they have decided today that the prices will go up. They have made a tax on electric energy and gas. Then you have to add the basic price for being connected to the grid, and you get 1,250 euros for electricity, typically. And if you have a 10 kilowatt system and have no ideal conditions, so it's not exactly in the right angle, and not in the south part of the world, or where I live, or Brian lives, then you get a little bit less than the ideal. Typically get from 10 kilowatt in Germany, get 10 megawatt per year. But you can calculate better with 8.
I see.
And even Radi calculates with 7 in Aachen, is it? So when you have costs, if you have a system without a battery, only a 10 kilowatt system, will nearly half, 60% of the former energy you have still to buy. So 40% you get from the grid, which costs 800 euros from the energy provider, and you sell 6 megawatt to the grid, you get 480 bucks back. And you see, with this simple solution without battery, you have a net interest of 930 euros per year. Then you can calculate that.
Okay.
It's very simple. If you spend 4,000 bucks doing your self solutions, you have 4.3 years and it's paid off. If you have a company with, you have to pay 40,000 or more, you have to wait 15 years or more until it will be even. And if you add a battery, typical 10 kilowatt battery, the calculation is a little bit changing. You get a little bit more, not so much more than people would think. You see, it's about 300 euros per year more. So the return of investment for the battery is not so high than you would think. And the return of investment.
If you would be two families with one house and one solar system, you just double these figures.
Did not understand that.
Two families.
Two families.
Just double it.
Double it or make at least 50% more.
Okay.
Or if two, 50% more, I would say, yeah.
Okay.
But if you have lower, the lower thing, no? It does not scaling linearly, no?
I see.
If you use 100 kilowatt solar system for a single family house, no, you will never have get that back from. No, you better get the money to the bank. Yeah. But even if you only can install 5 kilowatt on your roof, then the return of investment is faster than maybe 3.5 years. No, if you do it yourself, because it's so cheap. Maybe if you buy it from a company, if you buy only 5 kilowatt, they even say you have to pay $10,000 or a little bit more. So sweet spot is between 8 and 10, I think, for a single family house.
But yeah, people could say better wait, because the batteries will get even cheaper in 2 years, and the modules.
Yeah, but
is that a good idea, or?
Yeah, you can wait until it's cheaper, but I think even that it's not linear. The price drop is so enormous and has to do with politics, because China has an economic problem, and they manufacture batteries and solar panels, and have them they have to sell it for extremely below the price they needed to have that. They ruin the complete solar industry, which was sometimes big in Germany. We have now even not more, one company which is producing solar panels in Germany, even Switzerland. No, there's one one company which is producing inverters in Germany, which are really expensive. One is in Israel, but the concurrence through China is so high with these prices, no? So they can't go. Otherwise, they have to give it away for nothing.
Can it also happen that they will get more expensive again?
They could be. Could be, because they are below the price they need to. They can't. This is not a realistic price of this parts. Think of what even the inverters, the amount of electronic parts inside, high current devices, even the transistors inside are really expensive if they can handle several hundred amps, and so on, for the charge controller and so on. I can understand how they can produce that. So I will say should not expect that they will get really deeper. Maybe some percent, 10, 20 or so. But in this time, if you wait, you don't earn money. If you start now, you earn money in this time. And next thing you see, return on investment is not better if you use a battery, if you build it yourself. You only have a better feeling. And the one advantage of using a hybrid inverter with a battery is that you have a power outlet for emergency things, maybe for the heating system or refrigerators or the router of your internet router. You can connect that to that power outlet and have a long time of, if you have power outages, like in South Africa, would be a good idea to use a battery, and then a bigger ones, no?
Yeah, and not lead acid.
Yeah, and exactly. But in countries where it's very seldom that you have power outlets, no, then it's not a real advantage. It's only feeling. I know. I don't remember when the last outage was in my village. Several years ago.
Thomas, we're running up against time, and this is your last slide.
You see, if you add 5 kilowatt for the battery, you use a 15 kilowatt hour battery. You see the amortization period goes longer, not shorter. So a smaller battery is more economic. But if you use more panels, the amortization period goes shorter, and both parts. So the rule out of this is more panels are better, but not a bigger battery. So this was it.
Excellent, great. And I had a lot of questions, but I didn't want to jump in because I know we've got limited time here and a lot of questions. And as Hans de Jong said, it's very country dependent. So when you talk regulations and how much you can get from the government, you guys are in the same country. So it's equally relevant to both of you, but not so much for me down south here. Even our solar panels have to be north facing.
Yeah.
Rudolf said,
yeah, the big argument.
Rudolf was interested in different types of panels, vertical ones and inverters management systems and where to buy soon. But I mean, that's also country dependent where you buy.
Yeah, it is.
Using batteries under good power management may reduce the number of battery cycles toward the grid. Is this correct?
No, it's not. Okay. No, not correct. Because the inverter should regulate everything, and power management doesn't touch the battery cycle so much, and the battery cycles are low in a normal home installation, no? Between 10 years, between 1,000 and 2,000 cycles, typically. So if these are 100 more or less, doesn't care.
Okay.
Not important.
Now, where I am, I'm less than 28, 29 degrees away from the equator. So I'm closer to the equator, whereas you are maybe nearly 50 degrees north. So it's harder to get sun. A question from Jeff M. Is a sun tracking system advisable for more northern latitudes?
No. More panels is cheaper and more efficient because you even get diffuse light energy. No? Even in the moment, I have completely clouded and its sun is going down here. And I am on the 48 degrees now, north. And I got 100 watts from 4 panels in the moment. So if a bigger ones, no, if you have 40 panels, no, you get still a kilowatt. And if you if you're in Scandinavia, for example, no, maybe instead of a kilowatt you get 750 watt. Then not at the same time, no, because the sundown is earlier there.
Yeah, we have someone joining us from Saudi Arabia, so that's a great place to have solar.
Yeah,
over there.
Absolutely. Cover as much as you can is the answer.
Safety question. I've seen suppliers of even lithium-ion batteries recommend housing outside in case of fire. I think I would agree with that. What would you recommend, as here in the UK there have been many fires from pure lithium batteries from China? Yeah. Those things scare me, even in hoverboards.
Don't ever buy normal lithium batteries. Only buy lithium iron phosphate for that. Every other battery type is more dangerous or much more dangerous. And we haven't had fires in Germany too from that.
Yeah. Here's another question. Lithium titanate batteries. I'm not sure I've heard that term before. Are they safer for in-house?
Don't know. I first have to check the sources. In the moment, I don't know.
Okay, and then I've had as you can see, I'm rushing through this because I don't want to keep everyone too long. It's been an hour, but these are good questions. A couple of people have asked, what does the optimizer do exactly?
The optimizers, yeah, but it does. So if you connect panels in series, no, and one panel has not much light, the impedance of this panel goes high, and so normally the complete current can't go through this panel. Then the voltage over the panel goes negative and it's falling out completely, even if a part of that is going out. And then these optimizers take the energy they have. That is a little inverters, no? Have an input voltage and currents with a maximum power point regulation, especially for this panel, and give a lower voltage outside at the current that it's needed for the complete thing. So this is all. It's a better management of shadow. but I'm not sure if it's worth the effort. I personally would not do that.
Okay.
Because the anti-parallel diodes would be enough for most things.
Question here about battery capacity. This is an easy one for you, Thomas. Battery capacity compared to house consumption. In terms of autonomy from battery in days without sun, is there an economical cost limit for residential installations?
Yeah. I would not do it in this, how many times, how many days you can be autonomic. This is a different calculation. What I've done was a calculation for economic sense, not for being as long as you can be autonomous. So you can, this is a thing of personal wishes and what you want to have. If you want to be autonomy, you need a big battery. Okay, then you have to calculate what was the bill last year without this, and then you see typically how many kilowatt per day you use at night or so. Then you can calculate it, or at least estimate that. What I did was an ordinary house with 4 people, 2 small one, 2 bigger one, and with a 10 kilowatt solution. Then a 10 kilowatt hour battery would be maybe the sweet spot of that. More effective would be a 5 kilowatt because you use it more heavily every day. In winter, nothing. And even Radi has in his little wooden house, he uses a heat pump, and the heat pump nearly gets all the energy out of the battery. This is why he wanted to have a bigger battery, and there, in this case, it makes sense. So in spring and autumn, he would have no energy costs for heating, for hot water, also, if he has a bigger battery.
Okay.
If you have a big load, then use a bigger battery and more panels.
Okay, and I'll just say we've gone over the hour, but Thomas, if you wouldn't mind staying with us for a few more minutes, then I could say to anyone who needs to jump out, you can always come back to StreamYard or to YouTube, and this will be available on replay. And if you're looking for the presentation, Thomas's slides, yes, we will put up a web page with this after the broadcast, and then of course you will be able to download the PDF from there. And Annie thanks you for the calculations as well. If I've got a question for you, Thomas. I've got an inverter which I want to put close to the mains outlet box, the one with the switches, but the batteries won't be convenient there. How much efficiency, does it affect efficiency much if I want to run very long cables from the battery to the inverter?
Depends on the cables, the size of your cables. If you have a long distance, you thicker cables. And the type of battery, if you have a 48-volt battery, you have high currents, really high currents, with 10 kilowatt, you calculate it, 100 amps, and so on. And not more than you need 16 square millimeters cables or so, or more, bigger ones. So if you have a longer distance, bigger cables, and even the cables for solar systems, normally 4 square millimeters would be enough for connecting the panels. But
even at a distance of maybe 3 to 5 meters?
By 6 square millimeters, the standard.
Yeah, you would want to get the right thing. A question in German here asking if salt batteries are an alternative to lithium in terms of cost and environmental considerations.
Yes, there's people speak about that for more than 10 years, and I think they will speak more than 10 years more. So theoretically, in research, yes, but oh, sorry, not at the moment. In the moment, there's just one type of battery, no other solutions. Even flywheels and exotic things and pumping water uphill and so makes no sense for personal use.
You must have a hill for that.
Yeah.
Lake.
But Jens talked about this.
Hydrogen, there are systems which are producing hydrogen.
Especially if you have many panels and you can't use all this big amount of energy, then storing gas, producing gas yourself, with electrolytic converter into hydrogen, and wait until it's winter and use it then would be a good alternative. especially if you have bigger houses or maybe some buildings with 20 or more people, flats inside, then it would make sense because it's expensive, this technology.
Another question, if you could provide information on islanding. I mean, how inverters protect themselves from output short circuit when a grid outage happens.
They do that. They just do that.
I've got one.
Normally, if voltage is going below amount of different voltage, then it just shut off. They just shut off, typically. And islanding, all these inverters you buy typically for a house are not meant for producing island solution. They need special inverters, which are more expensive.
Okay, and I just want to get back to our giveaway, which I promised to do earlier. As I said, we are giving away copies of this book, Renewable Energy at Home, a hands-on guide to crafting your own power plant. So if you couldn't get enough from an hour with Thomas Scherer, here's another book for you. Now we've got the code word. You go to the website, elektormagazine.com/elektor-webinar-giveaway, as you see at the top of the screen and at the bottom of the screen. And the code word that you would put in there, big surprise, power. Fill out the rest. Prove that you're not a robot in this day of AI. Please prove that you're not a robot. And good luck to those of you who entering the competition. Question here, Thomas, about something called cell cubes. Do you know anything about those?
No. Didn't.
Unfortunately, neither do I.
Never heard that. No.
Good question here. Would it be possible to connect an electric car?
There are some cars which can do that, but it's a very bad idea to do that because the battery in a car is you should use for the car. It's a very expensive system, no? And if you use it for your home, I think you can have a long period of autonomy then, but I would not do that. Even if you stress a battery in your car, have fire in your garage, maybe sometime.
Yeah. These batteries do scare me. I mean, I've seen videos of laptops catching fire when on charge. So
yeah, ordinary. This is lithium polymer batteries, no? Which are the highest risk in getting fire because of weak compounds and they're not pressed together. They have no metal outside, no? And so on. And especially in cars, there are cells, round cells with metal housings, which are better. But lithium polymer, never for energy, only for laptops and for cell phones and so on.
Great. And also, I was interested in this earlier when you mentioned the anti-parallel diodes. Does it make sense to replace them with MOSFETs or ideal diodes?
Yeah, if you get some, if we want to have some milliwatts more put out, yes, it makes sense. But it would be technically interesting. I would not do that because this Schottky diodes are really good, and maybe it would make sense. I even have seen defective Schottky diodes, no? Because they're calculated very tight, no? Because of the price. You can check what kind of diodes is in the backside of the panel. You can open the little box and check it, and then you replace a bigger one. So the voltage, the dropping voltage over the diode is going down if you buy a bigger one or put a second one in parallel.
Yeah, it's all a question of efficiencies. I mean, I've got, excuse me a second. Got this project I'll be reviewing soon. It's a solar tracker, but it's a kit. It's more for fun than anything. And I'm wondering, based on the question we got from our northern latitude friend, how much power do these motors use to run the tracking? Isn't that going to steal your juice from the solar system?
Yeah, sure, it can if it has a battery. Yeah, then it costs not much power. The problem is not the power, but the installation costs, the mechanical things. And the space you need for all the controlling, no, on all these things, it must be stable, even if you have a storm and so on. No? This make it very expensive. It's not the cost of energy.
far latitudes
even the what you get of more energy is more than you need, much more than you need for controlling or for the motors. At least 10 times.
Another question from Elmar. Special is a heat pump in the house, 10 kilowatt hours a day in summer, but 35 kilowatt hours a day in winter at low radiation. Can you tell us how to handle this?
As much solar panels as you can get. Then you have, even in winter, see a good amount of energy, even from cloudy skies. So today I asked at 2 o'clock, I asked my friend how much energy he got, because it's cloudy in Aachen too, no? At the moment. And he said he got about 2.5 kilowatt hours energy from a 15 kilowatt hours kilowatt peak system. And it's not nothing. But if he would go to the limit, he would get about 5 kilowatt a day. So from 35 kilowatt a day, you can calculate that if it makes sense or not. I would say I would not do that. Then I would use a benefit in spring and autumn and summer, and in winter you have to pay.
That does make it complicated. Daytime, nighttime, and some people in the world, they don't rely on electrical energy as much for heating, especially in cold places. But yeah, we're very guilty of that in South Africa. It gets a little bit chilly, put on an electric heater.
Yeah, but even heat pumps are good solutions if you have a good temperature source, like a garden also. In winter, in northern parts of the world, or extremely south parts of the world, like Argentina also, you have with air-based heat pumps, you have not as much energy. So my friend, his heat pump has this number, which makes the mean number over the year from energy has to put in and energy gets out is nearly five times. Wow. But he has drilled holes 200 meters in the ground.
Yeah, that's expensive. I think.
Expensive, yeah, exactly. The whole heating system cost him 100,000 euros.
How will he recoup that?
Never. He was a happy guy because his old heating system was destroyed with this big flood 2 years ago. And then where he had 2 meters water in his garden. And then the government is giving him nearly all the money, 90% of that. So he said, okay, take the big thing. But personally, for one family home, 100,000 euros for heating, it's impossible.
Yeah.
So, but there are cheaper systems. Is this a different thing? Maybe we can, one time we make a webinar about, what about heat pumps? No? How can you use it?
It's also interesting, yes.
Yeah. And what are the pros and cons and what you have to consider in that?
We'll have to keep that in mind.
Is the heat pump also storing energy in some way? Is there a delay between...
In water, if you have a hot water storage. Yeah. And this is what some people do with the excess of energy from solar systems. They have some kind of heating element in the storage of the warm water, which you use for a shower and so, and put it in that instead of selling that to the energy provider.
I see. And that makes sense?
Yeah, economically makes sense. Economically.
Okay.
And even there are small heat pumps, especially for the hot water, of about 1 kilowatt. They need about 1 kilowatt energy. Then you get about 4 to 5 kilowatt heating energy. No? But this would make even more sense. Buy only a small one, then they are cheap. The systems cost about 1,500 to 2,000 bucks just for the hot water. And if you install that and use the excess energy for that, this is a really good solution. Then you don't need energy heating or for hot water between March and maybe November in Germany.
I see.
Well, I think we'll wrap it up now. We've run up on time. One question, could we collect some offline feedback? Yeah, sure. We always welcome feedback. If you want to get a hold of us, we put it up on screen. You can reach us at editor@elektor.com. Before we do go, I want to show you this picture sent in by our viewer, BGV. He's washing the dishes, but he didn't want to miss this, so he's checking us out next to the sink. I also want to tell you about our upcoming webinar, which is over here. It's coming up on the 20th of February, if I can get the window in the right place. And it's from ST Microelectronics. There it is. They'll be bringing you an exclusive webinar on the new AI accelerated STM32N6 microcontroller. So if you're into AI at the edge, this is something you won't want to miss. We'll be showing you step-by-step how to get started with the STM32N6570 Discovery Kit. Plus, there's a live Q&A where you can ask us about the upcoming STM32 Edge AI contest, where you can compete for a €5,000 grand prize. And plus, they give you the goodies to get your project ideas going if they're approved. So that's 2 weeks from now, 14 days, Thursday, the 20th of February. And with that, I'd like to thank Thomas for joining us and spending way more than an hour with us. I hope your voice is okay after this. And we had a tremendous viewership. We still have 385 of you still with us after an hour and 17 minutes. So thank you for taking that extra time, to all of you. I know it's not cheap time. Thank you, Thomas.
Thank you for good questions. No one
thank you. Yeah. Thank you, Jens, also joining us from Germany. Hope you have a good trip home. I don't know if it's probably dark there already. It's winter up there.
Yeah, it's nearly dark.
And down here it's still summer, so I'm sweltering slightly, but I do have the heat pump, i.e. standalone air conditioner, which blows cold air out the front and hot air out the back, so got to get it out the window. But I'll survive. Thank you very much, Jens and Thomas, and thanks to our viewers from around the world. We'll see you at our next show in 2 weeks. Good night.
Bye-bye.